Here we are dividing rational expressions. We have 36n squared minus 64 divided by 3n squared plus 10n plus 8. All of that divided by 3n squared minus 13n plus 12 divided by n squared plus minus 5n minus 14. Okay, so plenty of factoring to be done here. Let's first remember P over Q divided by R over S. You multiply by the reciprocal of the second term, so it's just P over Q times S over R. So that's the first thing we'll do. So let's just deal with that first. 36n squared minus 64. The first term remains untouched. 3n squared plus 10n plus 8 times, and we swap that second term. We flip it, multiply by the reciprocal, n squared minus 5n minus 14 divided by 3n squared minus 13n plus 12. Okay, now we're in business. Let's see, this one here, this 36n squared minus 64 is the difference of squares. And something funny is going on here. Watch. A squared minus b squared. Okay, a plus b. So this is going to be a cautionary tail. A minus b. So we can factor this as, so this is a perfect square, so we can factor this 36n squared minus 64 as 6n plus 8, 6n minus 8. Right, and it's tempting to do that and put those in as our factored form, but here's the cautionary note: those are not factored completely. Right, these are not factored completely. Look what can happen. We can factor a 2 out of each of these. So we factor a 2 out of the first one. That leaves us with 3n plus 4, and we factor a 2 out of the second one, and that leaves us with 3n plus 4. This is a 4. Okay, which then we can combine those 2's by multiplying, and we get, let's see, this should have been a minus 4 right here. Okay, minus 4. Okay, so then we combine these two 2's, and we get 4, 3n plus 4, 3n minus 4. Okay, so here's the moral of that story. Always factor out the GCF first. Right? Always factor the GCF first. Okay, so what went wrong here in this first term? Well, what we did up here works, but a lot of times people don't see it. They see the factored form, and they don't see that they still need to factor out terms, in this case a 2 from both of these. So what would have been better is to look at this and notice, oh, we can factor out a GCF. That GCF happens to be 4. So let's start this again. A 4 comes out right off the bat, and we're left with 9n squared minus, well, 64 divided by 4 is 16. Okay, and then we can factor those out, giving us 4, 3n plus 4, 3n minus 4. That's just a safer way to go, because then we see that we get everything we need, and it works out. Okay, so all of that to say, this is how we factor the first term. Okay, let's keep factoring. Let's do this term down here, this trinomial. Right, I'll use the diamond method here. So this says AC goes here, B goes there, and then AX goes here, AX goes here. Well, A is 3, B is 10, C is 8. Okay, so AC is 3 times 8, 24. B, well, that's just 10. And then AX, well, we'll just write that in. And it's not X in this case, it's actually N. So let's see here. So we have 3n and 3n. Okay, so we need factors of 24 that add to 10. Factors of 24 that add to 10. Well, 1 and 24, oops. 1 and 24, that's certainly not it. 2 and 12, maybe if we had a negative in there somewhere, but we don't. So not 2 and 12. 3 and 8, nah, doesn't do it. 4 and 6 is what we've been looking for all this time. Look at that, 4 and 6, because 4 times 6 is 24, but 4 plus 6 is 10. So it's 4 and 6. 4 and 6 go like that. Then we do our cancellation. Let's see, can't cancel anything on the left, but on the right we can cancel the 3 and the 6, leaving us with a 2 on the bottom. So here is the factored form, and we read it down like this, So 3n plus 4, n plus 2, the factored form there. Okay, let's next do the second one here, the second trinomial. Okay, so we'll do our diamond method again. A times C goes in the top, so 3 times 12, 36, and B goes down here, negative 13, and AN will go in both of these sides, so 3n in this case, and 3n over here. Okay, now we need factors of 36 that add to negative 13. Okay, well, 1 and 36 doesn't get us there. 2 and, what is it, 18? No, I don't think so. 3 and 12, I'm not seeing it. 4 and 9, I am liking. We just need to mess with the negatives a little bit, but 4 plus 9 is 13, so we're close. We just need to make that negative 13, but they still need to multiply to get 36, so let's go negative 4, negative 9. There we go. Multiply to give us 36, add to give us negative 13. We are in business. So negative 4 goes here, negative 9 goes there. Let's do our cancellation. We can get a 3, cancels with the 9, leaving us with a 3 down here. And now we just read them off, going from top down. So our factored form here is 3n minus 4 and n minus 3. Okay, whew. This is getting a little bit busy. Let's see, for this one up here, right there, let's do that one in blue. Let's just use trial and error on this one, but you could also use the diamond method. Let's see here. In and in, we need factors of negative 14 that add to negative 5. Factors of negative 14, so I'm thinking negative 7 and plus 2. Negative 7 and plus 2, right? If we do a quick mental FOIL check, just to verify that we get this back, first outside, inside, last, yes, it works. So that is our factored form. Okay, so that's trial and error. You could have used that for any of these factors. Okay, well, now we need to clean this up. So let's rewrite it here. So we have 4, 3n plus 4, 3n minus 4. Okay, that takes care of the first term. Now our second term was n minus 7, n plus 2, all over. Okay, going down to our bottom two terms, 3n plus 4, oops, 3n plus 4, and n plus 2. That was just this term here. And now I'll get this last term, 3n minus 4 and n minus 3. Whew. Okay, that was a lot of factoring. Let's do our canceling. Okay, so let's see, what do we have? Check this out. 3n plus 4 and 3n plus 4. 3n minus 4 and 3n minus 4. N plus 2 and n plus 2. That was a lot. Okay, so 4n minus 7 divided by n minus 3. There we go.